We're going to proceed directly with our panel. Paul is on the panel, and if I could ask the panelists to come down. If there are any questions for Paul, let's do it in the context of the panel. And each of the panelists will give a brief presentation, and we're going to begin with you, Brian. I didn't tell you that. You're first, and then we'll have a presentation by Dave Wolter of AT&T Labs, and then final presentation by Tom Sawanobori of CTIA. So I'm just going to queue up the presentations here. That was too easy. All right.
All right.
All right, so Brian
here.
Markwalter of Consumer Electronics Association.
All right, thank you, Peter. All right, good morning, everyone. And again, I'm Brian Markwalter. I'm Senior Vice President of Research and Standards with the Consumer Electronics Association. And we're we're known pretty well in DC. We have a very strong lobbying organization. We also do market research that I'll tap into a little bit here, and maybe best known outside of DC for the CES, our trade show in January every year that I hope many of you have been to. If not, ask me about it, but it's the world's largest technology trade show. Happens in January, so you see pretty good bit of coverage even in the popular press about it. Rather than diving into architectures, because people are going to hit that pretty well today, I wanted to spend a little bit of time around motivation, what consumers own and buy and think about, which I think will dovetail with a lot of what you're hearing about trends here. CEA does have a market research department. That's part of what I do, and we do a big annual study usually in April each year, and we call that our ownership and market potential study. So we ask questions about what people own and about what they intend to buy. So we've done this many years now, more than 10 years, so we have a long track record here. We can kind of see what moves and what consumers own. So if we look, this is strictly asking consumers what they own. We can see here television still is at the top. You know, interestingly, when I was first in this industry in the mid-90s, we were asking about phones, and that included cordless phones. And phones and TV were roughly equal, about 98-99% penetration. Not everybody owns a television or phone even today. Sort of interestingly to me, optical disc, DVD and Blu-ray is still pretty strong. We have a new generation that the Blu-ray Disc Association has announced, so there's a lot of speculation as to what streaming media, what impact that's going to have. Honestly, I don't think we know yet, but in January you should see some of the first Ultra HD Blu-ray players. There have been some prototypes shown, but no commercial products announced. Smartphones have risen very quickly. We can see there it's 72% household penetration in the U.S. Oh, I should mention, this is U.S. data here. Laptops, notebooks at 67, and digital cameras at 64. And you can kind of read into this. I didn't put direction to it. Television is pretty stable. It probably would have been 98% for a long time. Blu-ray, the optical, I don't know. I'd say stable, but maybe declining. Smartphones obviously increasing. Laptops fairly stable. They've displaced desktops, of course. And digital cameras are one of the segments, although the penetration is pretty high, it's been decimated by smartphones. There are certain segments like action cameras that are doing okay, but digital cameras themselves have struggled. So this, when we ask about, or when we compare, this is a straight comparison of last year's data to this year's data, and you can see, now, again, this is as reported by consumers. So we ask them what they own. We also ask them about how many. So you can see tablets have had the greatest movement upward, smartphones second. Fitness trackers third, actually. They did really well in the holiday selling season. But also keep in mind, so if we did like a highest percentage growth, fitness trackers would be off the chart because it's they're coming off a small base. So you can see it went from 5% to 11%, pretty big growth. But that does not mean it will necessarily maintain that trajectory. I think there's a lot of room for them to grow. Digital media devices are like Roku's, Google Chromecast, and other streaming devices. In-vehicle communication are like accessories for bringing devices into cars. And I think this aftermarket industry has been tough because cars now have very good built-in electronics accommodation. Looking at CE product ownership, so we kind of put it all together. The left side over here is 2014, right side is 2015. You can see TV is still at the top, and what we do is so we take number of households and what they say about how many they own of each. So of course it's not uncommon. The ownership per household in the U.S. of TVs, for example, is a little bit more than two TVs per household. We have 117 or so million households the way we look. But you can see how quickly smartphones have risen. If you just think of per year annual sales of smartphones, they're super strong. Definitely beat TV. Blu-ray, as we noted, is still up there, and then coming down a little bit. Headphones are up there very high because we listen to a lot of stuff while we're mobile, to Paul's earlier discussion, and we also go through a lot of them. So if you've ever washed them, left them on a plane, whatever, we burn through a lot of them. Then laptops and on down the line there. Okay, part of what we also want to understand is what are consumers planning on purchasing. So probably not surprisingly, and maybe good for carriers and others, is smartphones are top of the list, 31% purchase intent. This reflects not only is it still, I think there's still room for more penetration, we're still displacing a few of the basic phones, but in addition to that, its upgrade cycle is much faster. Headphones, as I mentioned, there's quite a bit of attrition in headphones, so as you upgrade and find, it's not uncommon for people to have a headphone that they use in, say, a travel situation that's different from what they use in exercise. TVs always hold steady, and so I think this reflects replacement cycle. We went through a big selling cycle when we transitioned to digital TV and to flat panels, so there's a huge peak in sales. And we're down, we've been curving down, but I think we're going to come back up because we're now, a lot of those TVs are 8 years old or so. And so 21% reflects like the 35 million or so TVs we sell per year. Laptops right there with it, and even Blu-ray players. And I think this is part of how many movies we own at home still, and you have to keep playing them. All right, so things at CEA, what we're watching, and actually I think this will come up more and more. Internet of Things or Internet of Everything, to use some terms. Within CEA, of course, Internet of Things is all things to all people. We laugh about it. There's one of my engineers, there's a Venn diagram that's the universe, and then IoT is sort of like just a fraction smaller than the whole universe. So we tend to think about in terms of verticals. So connected home is one vertical. Obviously medical is another vertical. Transportation is going to be big. We believe very strongly that there's going to be a huge transformation in our transportation industry as we move towards self-driving cars and just whole different models about mobility. And that's going to take a lot of data to do that. Smart cities, we know if you just look demographically around the world, there's a big trend towards urbanization. There's, I forget how many, like 150,000 per day that are moving into urban areas. So we get this big urban effect. And in that, I believe, so smart cities is another one of these umbrella terms. What's going to matter is putting the data to work is the simplest way to put it. Because what is smart for Amsterdam may not be smart for Washington, D.C., and may not be smart for, say, Shanghai. So there's a cultural and local impact to what makes sense in terms of your own smart city. But behind that is clearly going to be data and data availability. then actually an area we're in right now are visual experiences. So consumers have always been willing to pay for entertainment and visual experiences. That's what drove TV sales in the 50s. That's what displaced movie theaters. It was the convenience of getting that at home. So we're switching over to ultra high definition now. If you've looked around, you can see some amazing TVs. And not only ultra high definition, which is the roughly 4K resolution, but high dynamic range, wide color. So our TVs are able to produce more and more realistic images. And then we'll also see a lot of great things going on in virtual reality and augmented reality. And those two things can kind of blend together. You see certain companies like Oculus that are after the VR portion, and a lot of others pursuing AR type applications. And there's plenty out there now that you can do with your smartphone. The FCC, I think this will come up in a few people's presentations today. The Technology Advisory Committee in the FCC has actually been doing some precursor work, I think, to where we're going in mobility and network. So back in 2012, I chaired the multi-band devices working group back in 2012. And the question back then was, you get all this band proliferation, phones having to accommodate more and more bands. Are the number of bands going to outrun our ability to build them into phones? And so the general conclusion was eventually, and the question is the timeline, but eventually phones will be agile enough that the band proliferation won't matter. But in the meantime, the industry gets so good at today's technology, we can add bands. There's some agility, antennas and other things. Phones are getting smarter. But for right now, it is sort of a multi-band prospect. We've just learned how to accommodate multiple bands. That will remain a challenge. Spectrum Frontiers was the group that looked at sort of above 6 gigahertz kind of range. We looked on out to terahertz, but one of the things that came out of that was this recommendation about 28 gigahertz that's now a proceeding. Advanced Sharing was looking at the techniques that are going on that are being considered, for example, in the 3.5 gigahertz proceeding. So what do we do to accommodate more spectrum and allow it to be shared? And then this year we have one on game-changing technologies that's looking at fundamental. We're spending a lot of time on software-defined networking, network function virtualization, massive MIMO, a lot of stuff that is being covered in 5G. So it's kind of interesting to look at those and project forward. So this is my conclusion slide. I don't know that I have, I'm not as much of a 5G expert as these guys are, but when I look at it, I think of just what consumers will expect. And we know that right now, they'll watch video on whatever device they have. So if they get home and it's convenient to get in front of the TV, they will. If they're mobile, they'll watch it there, and they'll watch the best possible thing they can. So that's just going to continue. They'll just expect their content to just be there. I think kind of gone are the days of, for the most part, linear TV. There are some event watching that's, people expect to be at a certain place at a certain time. Balanced band proliferation with a consumer benefit. So in that, I mean that as we add bands, the consumer and the service provider has to get enough benefit. So adding a band better delivers some tangible service to the consumer to make it worthwhile. That's going to be a big deal. We cannot slice this super fine and just add a bunch of bands, or at least not as we understand technology today. Get spectrum in the pipeline. So we're doing some great things. Of course, CEA is anxious for the incentive auction work to proceed and come to conclusion. But we talk about people kind of hoarding spectrum. I'm not convinced. I think there's plenty of consumption such that we need to keep the spectrum moving in the pipeline. And lastly, let industry drive technology and standards. I think Paul put in there working together with regulatory. That is true, but when we look at, there's some interesting discussions going on around, for example, LTEU and other things. CEA believes that those fundamentally are best worked out in industry. They're complicated, data needs to come out, some fairly rigorous testing needs to happen. And to me, that can happen in industry. As long as those conversations are happening, then we should let that proceed. And I'll leave it at that. I know you want to stay on schedule, Peter.
All right,
that's it.
great. Thank you,
All right,
Brian.
thank you.
All right, Dave, I'll put your name tag up there. So, and let me just.
Okay, bring out the PowerPoint. Okay, because I did have one build slides.
All right. Yes. All right. Our next presentation is Dave Wolter of AT&T.
Well, good morning. I lead the radio technology team at AT&T Labs, and so 5G is something we're doing a lot of work on today in addition to LTE Advanced. Thought I'd give you a little bit of background on some of what we consider to be really important as part of the key trends and needs in 5G, and there are plenty of issues for us to deal with as well. 5G, in our view, is going to be inherently a multi-RAT technology, RAT being radio access technology. So we're not going to talk about 5G replaces LTE, replaces Wi-Fi, and so forth. It's really more around how do we use all of those things effectively and efficiently. So we're going to see 5G tied together with LTE, tied together with unlicensed. All these things need to come together in a coherent way. We need a series of requirements as part of 5G which seem to be somewhat mutually exclusive, right? We want very high data rates, and people are talking in the gigabit range. At the same time, we need to handle the Internet of Things, and we're talking massive numbers of devices that are connected to our network and providing maybe small packets a few times a day. And at the other end of the IoT range, we have industrial IoT needs, where perhaps it's got to be low latency and very high reliability. And that has very different kind of requirements. So you got to put all of these things together, and what that means is that we've got to have a very flexible radio design and a flexible network design to make that happen. So we're going to have simultaneous connections to new devices, or to the devices. We can't rely purely on millimeter wave. That seems to be what's getting most of the attention in 5G these days. But if you think about millimeter wave and the propagation characteristics of millimeter wave, it's pretty much line of sight, right? So I can be holding a phone to my head, if that's what I'm using, in millimeter wave, and turn my head and go from a great signal to no signal at all. So how do I provide reliable service that way? And how am I going to have broad area coverage to keep a particular customer's session working when I may be moving in and out of these different small cells? So we need something that's under 6 gigahertz as a new 5G radio technology, and one that's going to be efficient for small packets in the IoT, but has also the flexibility to provide broadband services and provide control to devices that are going to be using millimeter wave. So we anticipate the control signaling and the common signaling to go across this sub 6 gigahertz channel, and then the very high throughput to come across the millimeter wave. That's going to need a new type of radio design. Today we use OFDM, where every subchannel is orthogonal. That's probably not going to be the case in 5G. We're going to need a radio technology that is very flexible in terms of subchannel size and the ability to provide different services with different requirements on the same physical channel. The other thing we'll need to do, of course, is add a new millimeter wave radio technology. And there, large-scale array processing is going to be very important. So full-dimension MIMO is being worked today in the standards, also called massive MIMO. You hear both terms. And we're going to have to probably move towards hybrid beamforming. While we'd like to do everything in digital beamforming, when you get to millimeter wave, and we're probably talking maybe a couple hundred antenna elements, we can't process all of that purely in a digital form. We don't have the power or the money to use all those A to D converters. So it's going to be a mix of some digital beamforming on top of some analog beamforming. The other thing that's really critical in this whole area is backhaul. So if I'm going to have all these small cells around, and we're seeing this already today in LTE where we're trying to deploy small cells, how do I get the backhaul to all of those different locations? It's not on a tower anymore, it's on a building, on top, it's on the side, it's on light posts, whatever it may be, which typically don't have fiber to them. And our problems here in the US are somewhat different than the problems in, let's say, Asia. You know, certain parts of Asia, fiber is very, very available. Here, dark fiber is just not so available to us. So how do we do that? And we think that's going to bring in self-backhaul capability as a key part of 5G. The other thing is network slicing, which you heard referred to before, so that I can take that core network and have dedicated aspects of that network for IoT behaving differently than broadband, behaving differently than some other application. And it's going to be required, you know, for ultra robust and resilient services on top of kind of best effort broadband and low latency services in particular. And so much of what you heard Paul talking about is going to be really critical to us here in terms of software-defined networking and network function virtualization. A couple of things I really did want to put some emphasis on is the self-backhaul problem, and that's going to have to be wireless. So now that we have these millimeter wave small cells out there, we've got large arrays with those small cells, we can use those arrays to also provide the backhaul link to some access point where there's fiber location. That also gives us the possibility to do communication between those small cells and very low latency characteristics, using the same time and frequency resources that I'm using for access because of the very tight beam width. That'll be necessary. Another thing that's going to be pretty necessary to us, we believe, is more of a virtual cell approach. So instead of having your device is talking to a given cell and that's identified, and as you move, then I hand off to another cell. Well, the reliability of doing that with millimeter wave in particular is going to be much more difficult to achieve. And what we need to be doing is having multi-transmission point services. So now I'm talking to multiple of these small cells at the same time to be able to get, number one, the higher spectral efficiency, and number two, better reliability. So as it moves, the cell effectively moves with the device instead of having static cells and I move between those cells which are identified. Okay. As we move to more and more densification, we'll be able to provide these higher throughputs. Again, much of that's going to be dependent on how we are able to transport and how we do this joint transmission. We will probably need to do something here on the right where I'm showing maybe a transmission point group on the left side and a group on the right side. I may be talking to that device from both of those groups. But the kind of techniques that we want to implement as part of the new radio technology says I need very low latency communication in some cases, and in particular within any of the transmission points that are in a specific group. And then maybe lower or a little bit worse latency can be had between the transmission points of different groups. And that's going to mean that we have to think about our layers a little differently, right? So maybe per transmission point, or what you might think of as a base station or small cell, I have layer one where I do my sampling, my time to frequency, do my multi-antenna processing, because that requires, number one, a lot of data, right? And I can't afford to run all of those fibers back to some centralized point, but it requires very low latency operation. Now, can I split layer one? Whoop, that wasn't what I wanted to do, was it? Okay. Can I now split layer one and put part of layer one back in a more centralized location, part of it out here where I'm doing this very low latency processing and the processing that's going to be required for all of the antenna processing out here at the transmission point, still be able to run a low latency transport here, perhaps probably wireless backhaul, and then have your layer 2, layer 3 also at the central point, and then with a different transmission group have layers 2 and lower as part of that transmission group, but do all of the layer 3 at a centralized location. So it's going to require some different approaches to the architecture than what we've been able to do before. You start to see some of the centralized RAN in Asia because they do have this, the dark fiber that allows them to have very low latency back to whatever centralized location. But we aren't going to have all of that, so we need to think about how we do this. And we kind of come up with sort of our view right now of how that division might be done and how the layers might be somewhat split here. And this is just right now kind of a proposal on our part. That'll be going through standards. But one thing we have to make sure we do in the standards for those of you who are US focused is we have to be sure that because much of the push out of Asia has some assumptions around the transport, that we make sure that what's realistic for transport in the US is also reflected on all of that standards work. Okay. Now I'm not a core network guy, but was asked to make a commercial for them. And so one of the other things that you look at, it's not just a radio change that we're going to be involved with here in 5G. It also has to involve the core. And we want to look at some of the design principles that you can see in papers from NGMN and 4G Americas and see where, you know, there are some limitations to the EPC that make it difficult to do some of what you want to do in 5G. So we need to be looking at how we minimize access specific nodes. We want a core network that we can divorce to the extent possible from access. We want those to be independent. We need a separation of the user and the control plane because typically you may need very low latencies on the control plane. You may not need those low latencies on the data plane, depending on the feature. One of the other characteristics is mobility on demand. So until we get to the ICN, right now we do have a lot of work to do to provide mobility. There's a lot of complication involved there. There are some timing issues involved there. And right now with LTE, there are very strict time synchronization requirements. What we don't want to have to do is provide necessarily all of that complexity for every device, for every service that we're running, because many of them are going to be stationary. So why add the complexity for those? So we need to have a network that can provide the mobility for those things that need it and don't provide all the complexity of mobility for those things that don't. Okay. Network slicing will be very important, as we mentioned. So kind of AT&T's views on the core network, which we've been bringing into 3GPP, is that this really ought to be a clean slate design. We don't want to just take the EPC and try to evolve it into something that can handle 5G because it brings a lot of baggage along. We think that needs to be a clean slate design. And we really do want to couple or decouple the RAN from the core network. We want to have this new core network be able to handle 4G, be able to handle Wi-Fi, any other kind of access technology that we want to use. So developing that new core network is going to have an impact also on the RAN core network interface. So instead of having an S1 interface and an X2 interface, we're probably going to need to look at different ways of interfacing the core network and the RAN. And those are going to have to be specified as part of the core network within 3GPP as well. So that's a 50,000-foot flyby of where we see 5G going. You know, people always ask, what's it going to be used for? And I would tell you, well, I know in detail that I have no idea what it's going to be used for. But it seems like every time we've given people more capacity and more speed, they find a way to use it. We know that we have to develop something with more capacity at lower costs than we do today because our cost curve is outrunning or is not keeping up. Our revenue curve and cost curves are not matching with our demand curve, and so we've got to do something here. that will provide the kind of capability they're looking for at a cost that we can afford. Good, thank you.
All right, thank you very much. All right. Okay, a final presentation before we begin our discussion is Tom Sawanobori of CTIA.
Good morning, welcome, and thank you for the opportunity to talk a little bit about the emerging architectures. So, looking at what some of the other colleagues, my other colleagues here on the panel have talked about, I'm going to try to put this all together, start a little bit with 4G LTE, where we are and how we got here, and then kind of look forward towards 5G and beyond. Okay, so first of all, where are we with 4G LTE? And I think some people, we've talked about 5G already, and 4G has been a great path and a great evolution for us, particularly here in the U.S. So we do have a strong leadership role here in the U.S. We've established that by, over the last 5 years or so, all the national operators deploying 4G LTE, many of the rural and regional operators, and today we have well over 98.5% of consumers have access to 4G LTE. That continues to be expanded with additional coverage into rural areas, in building and so forth. As of mid-year, about 183 million customers. That number continues to grow. One of the highest penetrations in the world, and I think the Ericsson Mobility Report from June of this year said that we actually have the highest penetration in the world in North America due to the aggressive migration from HSPA and from EVDO. A lot of technology advancements being deployed into LTE, and I think it's fair to say it's got a long, healthy roadmap. It's going to continue to 2020 and well beyond. So when we talk about 5G starting in the 2020 timeframe, plus or minus, I think we should recognize that 4G LTE is going to continue to be there, and notably also, almost every operator in the U.S. is on LTE, and I think that's the first time ever that we've all been on the same technology platform, kind of in the same time frame. So I think that's great. That's great for operators. It's great for suppliers. It's great for the scale economies that that'll benefit things like the Internet of Things. So a lot of things are happening in LTE Advanced. 2 carrier aggregation going on right now. Operators are deploying that. 3 carrier aggregation coming up soon. A lot of additional features in LTE Advanced. I won't mention all of them, but a lot of technology features that are advanced. Better performance, better interference management, right? So as we deploy more and more cells and they're getting closer together, we need better features like enhanced interference control, coordinated multi-point, and so forth. LTE and unlicensed spectrum is being talked about, advanced, and so forth, and that'll be potentially a new technology that'll go into unlicensed bands to help supplement the licensed spectrum in a supplemental downlink type configuration. And then we've talked a little bit about SDN and NFV, but that's going to be an important transformation. The core network that's served us well over the past few years has a lot of purpose-built platforms, whether it's the mobility management platform, the serving gateway. These platforms have served us well, but they need to be individually provisioned. They need to be grown and scaled individually. And I think that's where some of the challenges come as you look forward with kind of the growth. And in Paul's presentation, he talked about roughly a 6x growth. I think depending on which forecast you look at CTIA, we've been talking about over the next 5 years seeing about a 6x increase in growth. And that's not always, sometimes that happens faster in some of these urban areas than it does overall. But in general, we're looking at that kind of growth, and to grow not only the radio side, but you want to be able to quickly provision capabilities into the core network. There's a lot of move towards SDN and NFV technologies, fundamentally to enable lower cost deployments using commercial off-the-shelf hardware, really cutting edge capabilities, provision those much more quickly, add capacity much more quickly and then provision them really into a lot of network data type centers. So I think those are some of the benefits that we'll see, and that aggressive work is going on right now by a few operators to get that, kind of pioneer that getting into our networks. And I think you're going to see a lot of that being deployed to support the kind of capabilities we need. There's a lot of innovative services that either have been launched or announced. Voice over LTE. Paul mentioned that we designed the 4G networks principally for broadband access, but a lot of operators have spent a lot of blood, sweat, and tears over the last couple of years really getting that network optimized so they can carry real-time services. And that's not a small undertaking when you talk about what we've done in 3G. We really didn't have to do very much of that. In 4G, it's taken a lot more optimization, a lot more handoff optimization, management of the signal noise ratios and so forth in order to get voice over LTE working well. And that enables some rich communication services and things that you can do. So I think you'll see some of that. You'll see that enable other future services potentially that will come onto our network. So HD voice in a few years, when you get both of those voice over LTE devices coming together, end to end, you'll see a lot more high definition voice occurring. There's been trials on LTE multicast and broadcast, and that's really a capability that allows you to do things like real-time events, whether it's sports, a concert, something like that. I think these are things that are going to start to occur more and more on our networks. And then, last but not least is the Internet of Things, and it's really, principally it's been taking off, frankly, in 2G and 3G, but we know that in, roughly 5 years, maybe sometime sooner, 2G networks are going to be phased out, 3G networks are going to be supporting this, but we've really got that scale economy now starting to happen in 4G LTE, where it can really enable the Internet of Things along with other wireless technologies. So a very, very strong leadership position in 4G LTE. We'll continue to focus on this over the next several years to make sure we reap the benefits of 4G LTE and that our operators can monetize the assets they put into the ground. So, visually, kind of what do our networks look like? And maybe this is a little simplistic, but you've got a combination of today in this kind of environment, a little simplistic, of macro cells, we've got micro cells, you've got some home femto cells going in, you've got a lot of in-building deployments, and in the stadiums, you've got these massive, 60, 80, 100,000 people convening in one location, doing a lot of things in terms of, texting and social networking, video, and that's where one of the key challenges. We also need to serve a lot of uplink because everybody wants to take pictures and send videos. So those scenarios have driven a lot of things for distributed antenna systems and similar technologies up till now. So as you look forward, there's more and more demand for that. You talk to stadium owners, they want to do things like, when it costs so much money to take a couple people or to take a family to an event, they want to provide a richer experience for their clients, their customers that are coming to the stadiums. People want to do new things. You see a lot of technologies coming into the home, into the cities and so forth. So I think over the next few years, we're going to see a transformation from this kind of environment to something where, these things are already happening today, right? You've got smart home things starting to happen. So you'll see more and more connectivity going into the home, and things will be automated as from the time you leave home, or from the time you leave work to go back home, you'll have lights get turned on, you'll have appliances that, you'll have doors unlocked, you'll have things already set into your vehicle the way you want to have them set, and so forth. And you'll have, traffic safety communications that we've talked about. Collision avoidance systems are already being, self-driving cars have been already being trialed and tested, and our future networks will, potentially be involved in assisting those. You've got, we didn't talk about it too much, but in the broad context of Internet of Things, you've got a lot of low-power devices that need to be brought onto their network, and we need to think about how we can do that cost efficiently and effectively. That's being done already right now in LTE, trying to look at ways to bring low-power, low-cost devices with long ranges onto our network so that we can serve those efficiently. And then, sensor networks, they could be, throughout cities, they could be in other places. People have talked about using them in vertical applications. Somebody recently, I think the CEO of Ericsson talked about, they've got people that they're talking to that want to put them into agricultural applications where fields, vineyards, for example, or other areas have sensor networks that sense moisture and temperature and humidity, those sorts of things, and report them back and then automate the control systems that are going out. So there will be things like that that we're enabling, and I don't think we can predict exactly what will be happening over the next 5 to 10, 15, 20 years, but I think these sorts of capabilities will be enabled. And then I just showed some pockets of 5G. It could be in certain venues, stadiums, train stations, downtown urban areas. As Dave pointed out, in particular, that refers to the high, frequency millimeter wave technology. And I'll talk briefly about some of the attributes of 5G that are probably most relevant to start talking about. So we think about 5G, and this is a discussion that's still occurring. We're starting to socialize this with our members and so forth. But there's a lot of different things that are talked about in 5G if you've read some of the different white papers. But when we think about these, I think roughly, there's few main categories of technical attributes, and then these things will enable things like the things that I've listed here, and potentially other things as well. But you think about the millimeter wave technology, very high frequency, large swaths of bandwidth. It can deliver very high data, and it's ultra high speed. You've seen some of the trials that have been going on that show demonstrations of 1 to 10 gigabits per second, but that requires some new technology, some very attributes of very short ranges and so forth, and you can get potentially around a 50x gain in throughput. But again, that's going to be shared with some very high data rate applications. So you're thinking about some of the ultra HD video that Brian talked about. 4K video is already coming out, 8K, and in the future potentially augmented or virtual reality. And then there's targets for reducing latency by roughly a factor of 5. So the Airlink latency can be reduced. Then you can do things like interactive gaming, potentially some interactive things. I think you can see some industrial, Dave used the term industrial IoT or machine control. These things are the kinds of things that are being investigated, as well as improving, supplementing some of the vehicle traffic safety controls that are being discussed now. And then, last but not least, the verticals and the Internet of Things. We want to get, 4G LTE is a great technology, but it does have some limitations, in particular on the very large connection densities on a particular cellular sector. And so these are things will, ultimately, while they'll be continued on 4G networks today, in the future we'll want to have very, very high connection densities to support massive numbers of sensors, massive amount of wearables and tracking devices. I think, I don't think we even begin to think about how many things can actually have a wireless device on them. And it's not just person and my Fitbit and your whatever fitness device you're wearing, but I want to put one on my bicycle. I'm here in Washington D.C. I want to have one on my car. I want to have one on my briefcase. I want to have one on my dog. I'm probably going to have, I think we'll have those sorts of things going on in addition to many of the industrial and vertical applications. So things that'll enable many, many opportunities for growth in our industry and innovation. So what do we need to support all that? We're going to need an architecture that, as Dave showed and others, is going to support multiple radio access technologies, because 4G LTE is going to be very, very broadly deployed over the next 5 years. We'll continue to have Wi-Fi. We need to have licensed and unlicensed spectrum. We'll still have some, towards the end of this decade, we'll have 2G phasing out, but we'll still have some 3G. And then we'll have 5G emerging, probably both in some dense urban areas and then ultimately in a broad area coverage for kind of a control layer. And it's going to support all these applications. And what do we need in the core networks? It really is a transformation. I think Paul used that word. Not only the technologies, but we're going to have, first of all, this foundation of NFV and SDN, because we really need to be able to provide provision quickly. We're going to need to have the network slicing to support these wide range of applications. And then we have a totally different OANM paradigm than we have today, much more like the IT world. So in order to support this, we're going to need a range of spectrum capabilities, both low and mid-band spectrum below 6 gigahertz, and then high band spectrum as well. And very importantly, a flexible use policy. We don't want to be caught in the trap of assigning spectrum to certain bands, but we do want to have spectrum flexibility to go back, use 5G in existing bands or future bands that will be auctioned, and so forth. We need a lot of the technology planning and standards work that will be done in 3GPP and these other industry bodies. And we need to continue the kind of research and development and innovation that's made America great, so we can continue to find great applications and uses and efficient uses of the technology to support new growth for our industry. Okay, so that's pretty much it.
Okay, thank you very much. Whoops, I better. All right, thanks to all the panelists for the presentations. We're going to go a little bit into the break time for our discussion. I'm going to ask a few questions, but I want to turn it over to the audience fairly quickly. If you have questions, I think one question for Dave is, how is the schedule looking for 5G standardization? Are we actually going to be able to deploy standardized networks beginning in 2020, or is that too ambitious?
Well, the standard is scheduled to be completed in 2020, but there's also a look at splitting that first phase, if you will, into two different phases, one of which that might be deployed for Korea and Japan who want to deploy for the Olympics. That'll have one set of capabilities, and then a second phase that would have a second set of capabilities around 2020, and then probably the millimeter wave closer to 2022 is my guess right now.
So what would be a key feature of the first phase?
Broadband, I think, is really kind of the key approach, is to try to improve the spectral efficiency and the throughput that can be achieved on a wider bandwidth channel. So I think they're focusing on the 3.5 gigahertz channel, which is used very differently around the world than it is here. But much of the world has that frequency already set aside for wireless communication, as opposed to our government use and so on here.
And then maybe a question for anybody who wants to take this on. Small cells will play a huge role in 5G, especially millimeter wave will be deployed in small cells. Small cells have been challenging enough for LTE. Will there be something in 5G that facilitates small cell deployment?
I can comment on that. I think, small cells are going to be, I don't know that 5G is going to facilitate. One way to answer the question is you're going to need a lot of small cells and high density, the kind of flexibility that we'll be doing more and more in 4G LTE today. So the things that were mentioned, we're going to need to have backhaul, we're going to need to have some dark fiber availability. And I think the thing that 5G brings potentially is basically in-band type microwave backhaul. So you need a combination of those in order to facilitate that. And we're frankly need to get more better and more flexible siting, as well as more innovation, I think, in that. We're going to need cities and municipalities to be able to do things with us on light posts, lamp posts, and side of buildings, and potentially signage that's in cities in order to be able to ultimately deliver the kinds of capabilities that are envisioned in 5G.
Yeah, I might add, I agree completely with Tom. Just one point is we shouldn't forget that the whole cellular network is built on this idea of spatial reuse. And the ultimate of that is going to a small cell. So when we go to a small cell, we can reuse the frequencies more often than we do when we have a big cell. So this is one of the ways of getting very high capacity in a network without having to allocate new frequency spectrum. So when we talk about going to new spectrum, that's one of the ways of solving the problem of trying to get network capacity up. One of the other, or at least access capacity. one of the other methods is small cells. And small cells have been very attractive because it didn't require a lot of the regulatory effort and investment in spectrum to make that happen in the past. And the challenge has always been small cells are very inexpensive, but there's a lot of infrastructure that's required to support it, and that's a lot of operational complexity and cost. And so the sort of the balance in what's holding small cells back up until now has been largely not a technical problem, but it's been a problem that operationally they're just very expensive to deploy and manage and operate. And that's a problem that we're going to have to continue to work with technologies to try and come in. This gets back to, again, new economic solutions that enable these other things to happen more commonly.
I have more questions, but I think if anybody in the audience has a question, if you could just say who you are first, and then ask your question.
Yes, good morning. My name is Clovis Baptista. I'm a consultant, telecommunications and ICT consultant. I would like to know, my question is in regards to information-centric networking architecture, the content-centric networking. In this architecture, how do you deal with real-time communications like voice communications and machine-to-machine communications? This model is very much centered in content management. How do you deal with this kind of conversational applications?
Sure. It's probably a misnomer. The fact that that we call it content, one of the names for it was content-centric network, one of the implementations, and that coupled with the idea that there's lots of storage in the network has led to an association that people have that the reason you're building these networks is to replace content distribution networks, and we shouldn't really fall into that trap. It certainly does make content distribution much more efficient, but it also makes the management of networks much more efficient also. So there's the request response model very simply and logically accommodates real-time communication. You just wouldn't cache content for distribution in a real-time conversation in the network. You just wouldn't make use of that usage. But just as an example, having the content or having the storage in the network does facilitate real-time communication. It facilitates mobility. I'll just give you an example. It's not uncommon that you drop packets in a network. So while we're conversing, maybe not everything I'm saying is getting to you. So today we have a layer on top, TCP, or something like TCP, that retransmits end-to-end. But if I'm storing that information, every packet, for a moment in the network, then if I drop the packet someplace, in order to recover it and retransmit it, I can do that locally. I no longer have to go back to the source and ask the source, hey, can you resend that packet again from the end? So in fact, latency repair becomes reduced on an information-centric networking, even for real-time communication. The other application, or the thing I'll point out, is that we can do hop-by-hop congestion management. So that means when a network is getting congested, you can instantly reroute around a congestion point. We can't really do that today, except in a very coarse sense, in a very granular sense in our IP networks. So the ability to do load balancing dynamically right at the routed layer and congestion management hop by hop is another thing that sort of is a feature that emerges from this architecture. So we shouldn't really look at information-centric networking as the design purpose of this was for content distribution. It certainly facilitates content distribution, but it facilitates a lot of other kind of communication also. So I hope that helps.
All right, any other questions from the audience? Okay.
Hi, this is Rangam Subramanian. There was a discussion on Paul talking about networks, different kinds of layered networks collapsing and forming a single layer of network. I can see where Paul is coming from on that. But also we had the other thing on network slicing from AT&T, from David. So Paul, are you still seeing the network slicing within the concept you're talking, or it is all just universal, just boom, boom, boom?
Yeah, that's a really good question. I'll take this and then I can let Dirk follow. But when we're doing, there is a question, if you're really doing something transformational in the network, how do you actually take it from where we are today to this new model? And the whole evolution of network function virtualization actually facilitates our ability to make how to make that transformation occur in an economically realistic way. We're not going to take our current networks and throw them out and rebuild a new network on top of it. But then again, we should really remember that when IP emerged, we didn't take our current networks out and throw them out. What we did was we reused a lot of the resources that were in the network and built an IP network on top of that. And then slowly, we pulled stuff out from underneath it. One can think about building an information-centric network right on top of our current IP networks. And we just use the IP then in a different way than we use it today. Today we use it for end-to-end communication. In the future we can use it for transport between NDN-like routers in the network. The fact that NDN is a routing protocol means that eventually we could pull the IP functionality out from underneath it. We don't need to do that today. The NFV piece of it just says that those things don't have to be physical boxes. They could actually be virtual instances that run on conventional servers, and depending on what the transport requirements are and the performance requirements. So most of the routers that we've built today have in fact been virtualized and are running on servers rather than, they're just implemented in software. That kind of model fits very nicely into the NFV model. The network slicing actually provides something even more convenient, because the network slicing means we could have slices of a network that are conventional like cores, something like what our current LTE core is, and then we might have a slice that represents a slice of an NDN core and then route traffic that's intended for an application that can benefit more from that early on. And eventually you can see how you might start to migrate from the way we do things today to maybe what a long-term goal is, but doing that in a relatively gradual way. So the whole network slicing thing, I think, is completely synergistic or compatible with the idea of making this migration to an information-centric network. If you were going to ask me the details of exactly how that's going to happen, I'll start waving my hands. All right, that's got to get worked.
Dave, do you want to add to that?
Dave.
No, I guess the discussion around network slicing, I think, is somewhat independent of the ICN, really. As you move to SDN and NFV, now I've got the ability to take certain resources at a given time I need them, put the right software on there, and define the characteristics of the network that I need for that application at that time, while I can be using other resources on the same server, perhaps, that's conducting another function, another type of core network, if you will, with different characteristics for some other application. So that's really kind of where we were going with the network slicing. It allows me to optimize my core network for the applications dynamically.
All right, unfortunately, to stay more or less on schedule, we need to wrap up this panel. We're now going to take a break and resume at 11:15 for a keynote address by Maureen Alhausen of the Federal Trade Commission. Immediately after that keynote, we'll be going into the next panel. So the next set of panelists should check back there and get their microphones before we start the keynote. We will resume at 11:15. Thank you.